Welcome back, everyone. Today we are going to see another renewable source of energy, the energy contained inside the earth, that is none other than the geothermal energy, the thermal content inside the earth. So, straight away, we will move on to the topic. I hope all of you are enjoying my lectures. It is informative. Please share to the people in need, and if you have any doubts, you can revert in the comment section below. Also, I request all of you to subscribe and turn the notification on so that you will get notifications on every video upload. So in future I will be uploading, delivering you advanced features in the renewable source of energy, then a few more videos on execution of project, selection of project in the UG and PG level, etc. is also planned. So please do share with your friends and subscribe. So we'll move on to the topic, geothermal energy. So this will be the contents of the presentation on geothermal energy today. So the word geothermal comes from, again, just like thermodynamics, therm and dynamics, heat and power. Similar to that, again, this geothermal energy also comes from the Greek words geo and therm. In Greek, geo means earth, and therm obviously it is heat, similar to thermodynamics, right? So geo in Greek means earth. So from that, those two words, geo and therm, came the name geothermal. Okay, the energy, the thermal energy or heat contained inside the earth. So it is a heat from within the earth. It is a renewable energy source because, so mainly the geothermal energy is obtained in the form of hot water and geysers. So water is replenished every now and then by rainwater, right? Whenever rain happens, the water seeps into the earth's layers, different layers, and it will be the water going into the earth will be absorbing heat from the earth, and we will be getting that hot water by suitable mechanisms which we are going to discuss. So this is a simple form of geothermal power plant showing the different layers. Here you can see the magma, hot rocks, then hot water. The top layer is hot water. Until that layer under the surface of the earth, you may have to dig the production wells. Okay, depending on the temperature of the water, you may get hot water or steam, and that will be utilized as shown in this red arrows in the turbine generator combination to produce electricity, and the used steam will be condensed back using condenser and cooling tower mechanisms as in the case of a power plant, and will be returned to the hot water bed under the air surface. Okay, this is the simplest form of a geothermal power plant. Let us see how the geothermal energy is originated. As you know, the planet Earth originated from the sun several million years ago, and the temperature is getting decreased, it is getting cooled. Originally, the Earth was a mass of hot liquids, gases, and steam. As the fluids, that is the liquids and gases as well as steam, which was originally the earth, it was cooled eventually by losing heat to the atmosphere, the Earth's atmosphere, the outer solid crust, oceans, lakes were formed. So, by losing the heat, the outer solid crust, then water bodies like oceans and lakes were formed. Okay. The average thickness of the cooler outer crust, the thick crust, is about 30 kilometers. 30 kilometers. So this is a half cross-sectional view of the Earth's interior. There is an iron core, then magma, mantle, and finally the crust. You can see the relative thicknesses. The crust itself is very thin compared to the other layers. Again, this is a detailed view as well as you can see the temperature gradient here per kilometer. 1 Kelvin or 1 degree Celsius difference in temperature. Temperature is increased. So if you go to the from the center of the earth, if you come towards the surface, the temperature is shown here. The temperature change, variation or gradient is shown here. This is a crust, then mantle, outer core. So this is a temperature gradient for geothermal 30 degrees Celsius per kilometer. So per kilometer, you can see there will be a variation of 30 degrees Celsius or 30 Kelvin. Delta T will be 30 Kelvin or 30 degrees Celsius for every kilometer. If you go down from the surface of the earth. So the hot dry rocks, HDR, in short it is called, hot gases and liquids are deposited in the region below average depth of around 3000 kilometers. The magma is in the temperature range of 1500 degrees Celsius. So that much is the temperature of the magma or molten mass. The center of the earth, that is the core, iron core, is at a temperature of around 4500 degrees Celsius. So these are the structural details of the earth and its temperature gradient, and the temperature levels at different layers. Now, how the geothermal energy has evolved as the cooling happened. You know, all of you know that what is a volcano, right? So that is the result of losing of heat from the earth. We have seen that earth is losing the heat slowly from its evolution, right? So violent bursts ejecting this magma, hot molten mass, hot ash, then hot dry rocks, as well as lava. This burst ejecting these things from the earth's inner layer is called a volcano. Earthquakes as well as volcanoes occur in some sports occasionally. You heard about several news in the foreign countries where these volcanoes and earthquakes are occurring frequently, right? And the effect of volcanoes will be spread over several kilometers. But these volcanoes are really good sources of geothermal energy. There are several potential geothermal fields in and around these active volcano regions. So a geothermal field is identified in such a way that there is energy deposit available at a depth of less than 3 kilometers. If the hot fluid deposit is available at a depth of 3 kilometers from the surface of the earth, then we can call that region as a geothermal field. Because digging a production well or injection well more than that kilometer is very difficult, right? It's very expensive as well as it is difficult. So we have to get the thermal form of energy from a shorter depth from the surface, but also the quality of energy should be good. Otherwise, there is no meaning in spending the capital for that. Now let us see the important aspects about geothermal energy before going into the different resources and advantages and working. So we have seen that the different layers about 4,000 miles below the surface, geothermal energy is generated in the core, and it is slowly coming up radially outwards. It is coming because of the cooling action. So the geothermal energy is available, as I mentioned in the beginning, in the form of hot water springs, geysers, fumaroles, and volcanic eruptions. So it is available usually in the region of greater than 80 kilometers. It is very difficult to extract. In the previous slide, we have seen that when the energy is available for less than 3 kilometer depth is called a geothermal field. But usually this is available greater than 80 kilometers. Deep production wells are drilled in the geothermal fields for extraction. The application: direct use of hot water, then space heating, greenhouse heating in the cold countries, process heating for industrial purposes, mineral extraction, air conditioning, then obviously the common one, the electric power generation. The average geothermal gradient, as I shown in the diagram, 30 degrees Celsius per kilometer. The rate of release of geothermal energy is of the order of 0.06 watt per meter square. Per meter square area, 0.06 watts only is the amount of geothermal energy release. But as you know, it will be pretty large in quantity, the geothermal reserve in the earth, right? 4 into 10 to the power 12 exajoules. That much amount of energy is available in the earth. But we don't know where is the location of geothermal energy availability, and difficulty in extraction makes it very difficult to make use of this much amount of energy. Compared to solar, wind and all, geothermal energy is not very easy to extract. Only very developed countries where the sophisticated technologies are available will be able to find out the geothermal field. Even though they find out, it should not affect the population. All the things needs to be considered. So these are the engineering criteria for geothermal fluid. The availability, obviously, then the temperature. At what temperature the geothermal fluid is available? What is the rate at which it is available per day? How much volume, meter cube, we can get? Then how many years the production wells will work without any obstruction? There should not be any blockage in the path of production wells. It should work continuously. Then the aquifer. Aquifer is a large holes or cavities in the rocks, these hot dry rocks, where hot water or brine is available. So the depth or volume of the aquifer, depending on that, we can quantify how much energy we can extract. Then the mineral content. So from the geothermal energy we can get minerals also. So how much is there any mineral content available in the geothermal field or in the fluid what we are getting? So when we check the history, the first geothermal electric plant was installed in Larderello, Italy in 1904. So just few years back, if you check. Just 120 years back only this geothermal energy extraction is started to produce electricity. Now, as of now, say for some 2-3 years back, the total installed capacity is about 8,000 megawatts. Obviously, United States generate more geothermal electricity than any other country. In United States itself, California is having a large number of geothermal power plants, counting to 33. Nevada is having 15 geothermal power plants. Now there are two major classifications to the geothermal resources: hydro-geothermal energy resources and petro-geothermal energy resources. Hydro and petro. Sorry. Hydro-geothermal energy resources are the deposits of hot water and steam at lesser depths, less than 3,000 meters or 3 kilometers. So hot water, hot brine or steam can be extracted from such deposits by means of the production wells alone. Simply by production wells, you can have the hot water, steam or hot brine. So the cold water will be pumped down using a pump here. You can see a pump here. So cold water will be pumped. And this cold water will absorb thermal energy contained in this layer from the Earth's layer. And it will be moving up in the form of hot water or steam depending on the temperature to the generating station. So there will be two pumps, one pump for pumping down and the other one is to lift the hot water or steam up to the generating station. So there will be a boiler, turbine, condenser, cooling tower. Finally, electricity will be given to the grid depending on the production. So this is the hydro geothermal energy resources and production. Now coming to the second category, petro geothermal energy resources, which are commonly available in the hot dry rock HDR. The hot dry rocks at temperatures of around 2000 degrees Celsius. Can you imagine 2000 degrees Celsius temperature and around 2 kilometer depth form important deposits of geothermal energy. So there are two types of wells drilled in the hot dry rock sites: production wells and injection wells. So you can see here there is an injection well shown in this blue color and the production well here you can see. And a fracture is made in this hot dry rock. Okay. A pump will be pumping the water to the well here. I mean the HDR, hot dry rock, around 3 to 4 kilometers. Okay. Then the production well is here and this is the schematic of the power station. Fine. So the injection well can inject water and the production well will be taking back the steam or brine or water, hot water to the power station. Then after cooling down in the condenser, it will be given back to the injection well. So this line is meant for replenishing the water here. So this one. Injection well, this production well, again this is also the this is also the production well. I'm sorry, this is also the production well. So these two lines will be taking away the hot water or steam from the hot dry rock deposit. So this is the working. So water is pumped through the injection well into the HDR. Then the injected water collects the heat from the HDR and that will be taken back from the HDR to the power plant. So usually this petro-geothermal energy deposit HDR may deliver a mixture of hot water and steam of temperature up to 2000 degrees Celsius. Now discussing the different types of geothermal resources, let us see the applications of geothermal energy. Around 8,000 to 10,000 megawatts is the installed capacity. The applications involve from water bath to mineral extraction. And coming to the non-electrical applications, there can be space heating, greenhouse heating, as we have mentioned, air conditioning, medical therapy, mineral extraction, as well as process heat. So this diagram shows the top 10 geothermal countries in 2018 with installed capacity megawatts electrical. So total it is 14,600, more than 10,000 now. So top US, then Indonesia, Philippines. In India, the important hydro geothermal resources locations are in Jammu Kashmir, Maharashtra, Gujarat, and in Madhya Pradesh. So India has about 150 non-geothermal sites in the temperature range of 1000 to 1600 degrees Celsius, mainly in the form of hot water springs and shallow water reservoirs. But we are using it in very limited amount, the geothermal energy extraction, compared to the other renewable energy sources. So let us see the advantages. So direct use and heating applications have almost no negative impact on the environment. Right, directly we can use, there is no pollution at all. They do not burn any fuel to generate electricity. So very less carbon dioxide emissions because we need to use this pump and some form of moving equipment are required so that they deliver very less amount of carbon dioxide for the working of this moving components like pump is working, then pump should be required in the condenser, cooling power, cooling tower, etc. Geothermal plants emit 97% less acid rain. Very advantageous, very attractive. So the steam and water is not getting wasted. It is re-injected through the injection wells. So having said that, we will wind up the session on geothermal energy. I hope it was informative, interesting. You can get a lot more resources. This is just the fundamentals, brief discussion on geothermal as per the syllabus, because geothermal energy itself could be taken as a course separately. In that, different types of resources and the production well, types of power plants, everything will be discussed. Anyway, I'm not going to discuss all these things here. This is just a brief idea what geothermal energy is, how it is being utilized. Okay, and the applications as well as the advantages. Thank you for watching. Have a great day.